morning students. We have covered exercises 3A and 3B. So let us try out some worked examples from the textbook. So the problem goes like this. A double ordinate of the curve y square equals to 4ax is of length 8a. Prove that the lines from the vertex to its end are at right angles. So given parabola is y square equals to 4ax. Let us suppose that this is our parabola and this is our axis, principal axis. Here is the focus and this is our tangent at the vertex and this is our directrix. A directrix is the line which is perpendicular to the principal axis. This is our directrix. And what is double ordinate? A chord which is perpendicular to the principal axis. A chord which is perpendicular to the principal axis. So let us suppose that this is the chord which is perpendicular to the principal axis. X dash, y dash. This is our directrix L equals to 0. This is a comma 0. So if the same chord which is perpendicular to the principal axis and passing through the focus, then it is said to be a latus rectum. But here double ordinate. So let P dash be the ends of the latus rectum. Let us take AT square comma 2AT and this is AT square comma minus 2AT. I have taken the parametric points. Let P AT square comma 2AT and P dash AT square comma minus 2AT are the ends of the lattice rectum. Ends of the lattice rectum. Ends of the double ordinate. So the length of the lattice rectum is equals to how much? 8a. The length of the lattice, the ends of the double ordinate. The length of the double ordinate is what? P dash is equals to 8a. This is given. This is given. Given that the length of this lattice rectum is P dash equals to 8a. So what is P dash? Square root of P dash is the distance between the 2 points x1 y1 and x2 y2. Square root of x2 minus x1 whole square. 8 square minus 8 square gets cancelled. Y2 minus y1 whole square. 280 minus of minus. So 280 plus 280 whole square. So, but according to the question, this P dash is equals to how much? This is 8a. This 8a is equals to square root of 280 plus 280 is 480 whole square. Square root gets cancelled. This is equals to 8a is equals to 480. So a gets cancelled. 4 2s are 8. Therefore P is equals to 2. Therefore T, if you substitute here and here, then actually P is equals to how much? 8t square. T square is 2 square 4a comma this is 2 into a. So 4a comma 4a and P dash is 4a comma minus 4a. So what do we need to prove is, prove that the lines from the vertex to its end are at right angles. So this is the vertex. So the lines from the vertex to the ends of the double ordinate. So this and this is 90 degrees is what we need to prove. For this, is it not sufficient for us to prove slope of AP into slope of AP dash is equals to -1 to prove angle PAP dash is equals to 90 degrees. That's what we need to prove. Prove that the lines from the vertex to its means double ordinates ends are at right angles. That is PAP dash. Here 90 degrees is to be proved. So for this, it is sufficient for us to prove slope of PA into slope of P dash A is equals to -1. So what is slope of AP? Slope of AP is equals to how much? This is 4A comma 4A. This is 4A comma minus 4A. And since this is the standard form of the parabola, its vertex is at the origin 0, 0. So slope of PA is 4. This is x1, y1 and this is x2, y2. y2 minus y1 by x2 minus x1. So 4a minus 0 by 4a minus 0 into this is minus 4a minus 0 by 4a minus 0. This is equals to 4a by 4a is 1 into this is minus 4a by 4a is minus 1. So this is 4a by 4a is 1 into minus 4a by 4a is minus 1. This is equals to minus 1. Since the product of the slopes are equals to minus 1, then this is PA P dash, angle PA P dash is equals to 90 degrees, which we have proved. If Q is the foot of the perpendicular from a point P on the parabola, y square equals to 8 into x minus 3, which is not a standard form of the parabola whose vertex is not at the origin, to its directrix. S is the focus of the parabola, and if SPQ is an equilateral triangle, then find the length of the side of the triangle. Let us suppose that this is our parabola. So, given parabola is y square is equals to 8 into x minus 3. This can be written as y minus 0 whole square is equals to 8 into x minus 3. So this is our form. Y minus k whole square equals to 4a into x minus h. So here 4a is equals to 8 implies a is equals to 2, and focus and vertex A is equals to h comma k. So this could be compared with y minus k whole square equals to 4a into x minus h. In the place of h 3, k is 0. So 3 comma 0. So this is our axis. This is the vertex. This is our axis and this is our directrix. This is the vertex. And here is the focus S. So here AS is equals to how much? A. And A is equals to how much? 2. That means from here to here this distance is 2. And A is 3 comma 0. 3 comma 0. Then this is 5, 0. And this is the directrix. This is x, x dash. This is y, y dash. Okay. So this is x, x dash is a principal axis. This is our directrix L equals to 0. And this is the foot of this directrix Z. If AS is 2, then this ZA is also 2, because vertex, foot of the directrix and focus are collinear point lying on the same line, and A is the midpoint of ZS. So this distance and this distance are equal. And what more that is given is Q is the foot of the perpendicular from a point P on the parabola. Let us take this point P on the parabola. So what is Q? Q is its foot. Q is its foot. Q is the foot of the perpendicular of P on the directrix. So S is the focus of the parabola, and SPQ is an equilateral triangle here. So here SP I join and Q also if I join. So here SPQ triangle has been formed, and we need to find SPQ is an equilateral triangle here. That means this is 60, this is 60 and this is 60. 60 degrees each, since it is an equilateral triangle. And then find the length of the side of the triangle. So then each length of this triangle SQ and SP and PQ. Since it is an equilateral triangle, all sides are equal. So it is one of the side if we find, then actually the remaining sides are also the same. So that is the question given. Now here Q is the foot of the perpendicular of P on the directrix. Therefore, what is angle? This is totally 90 degrees and this is 60 degrees. Given that triangle SPQ is an equilateral triangle. This is an equilateral triangle and implies angle SPQ and angle PQS is equals to angle QSP is equals to 60 degrees and SP is equals to PQ is equals to SQ, since it is an equilateral triangle. Now, given that angle ZQP is equals to 90 degrees. Angle ZQP is 90 degrees. So, and this is 60 degrees. Then, what is angle SQZ? Angle SQZ. Angle SQZ. This angle is, this is totally 90 degrees minus this is 60 degrees. We will get this angle. How much is that? 90 degrees minus 60 degrees, which is 30 degrees. So this angle we got. Now in triangle SQZ, now sine 30 degrees is equals to, if you take this triangle, this is Z, Q and this is S. So this angle is 30 degrees and here this is 90 degrees, foot of the directrix, right? So sine 30 degrees is equals to, the side opposite to this angle is SZ by So what is the side opposite to this 90 degrees, which is hypotenuse? SQ. So this is equals to SQ. That implies SQ is equals to SZ by sin 30. So SZ by sin 30 is 1 by 2. 1 by 1 by 2 is into 2. So this is 2 into SZ. So 2 into, what is SZ? SZ is SA plus AZ. SA plus AZ. This is equals to, SA is 2, AZ is 2. 2 plus 2, 4. 4 into 2 is totally 8. So if SQ is 8, then QP is 8 and PS is also 8. So since SPQ is an equilateral triangle, therefore the length of each side of the triangle SPQ is 8 units. Find the condition for the straight line LX plus MY plus N equals to 0 to be a tangent to the parabola y square equals to 4x, and find the coordinates of the point of contact. So this can be done in one way, like let P x1 y1. See, this is the parabola given, and this is the point of this is the line given. This line is Lx plus My plus N equals to 0, and this is y square equals to 4ax. Let P x1 y1 be the point of contact of both the parabola and the line. Therefore this is said to be a common tangent for both of them. So at P x1 y1, the equation of the tangent to the parabola y square equals to 4ax is s1 equals to 0, y1 equals to 2a into x plus x1. So 2ax minus y1 plus 2a x1 equals to 0. X, y constant. This is the straight line. That is this line. According to the question, Lx plus My plus N equals to 0, which is also the same line. So since 1 and 2 represent the same straight lines, therefore comparing the quotients x by y by 1 by, so then actually we will get the ultimate answer. Otherwise, so that is one alternate which we have discussed before also in the exercise 3a. But what is the alternative is, let P at square comma 2at be the, so instead of Cartesian point I will take a parametric point. P at square comma 2at be the point of contact of the line Lx plus My plus N equals to 0 and the parabola y square equals to 4ax. So equation of the tangent at PT, which is at square comma 2at to the parabola y square equals to 4ax is yt is equals to x plus at square. This is the tangent. Equation of the tangent at the parametric point to the parabola y square equals to 4ax. This is x minus yt plus at square equals to 0. So, but according to the question, according to the sum, Lx plus My plus n equals to 0 is a tangent. So this is 1 and this is 2. 1 and 2 represents same lines. So now comparing, we get here x coefficient is 1, y x coefficient is L is equals to quotient of y is minus t by here quotient of y is m is equals to at square here. Constant is at square by this is n. So this is equals to 1 by L is equals to minus t by m. From this t is equals to minus m by L. So that is equals to comparing first and this. So 1 by L is equals to a t square by n. So this is equals to n by L is equals to a t square. A, what is t? Minus m by L whole square. So this is equals to n by L is equals to a m square by L square. A m square by L square. So this L gets cancelled. So therefore we get NL is equals to AM square is the condition for the line Lx plus My plus n equals to 0 to be a tangent to the parabola y square equals to 4ax. Now the point of contact is P is equals to at square comma 2at is what we have taken earlier. So a into t square, t is equals to minus m by L, t square is m square by L square, comma 2at, 2a, the value of t is minus m by L, minus m by L, this is equals to a m square by L square, comma minus 2a m by L, this is equals to m square by L square. So a into, so a m square is NL, NL by L square, comma minus 2amL. So this L and this L gets cancelled. N by L comma minus 2am by L is the point of contact. Prove that the normal chord at the point other than the origin whose ordinate is equals to its abscissa or subtended right angle at the focus. Since the parabola is not given, let us take the parabola to be y square equals to 4ax. Let y square equals to 4ax be the given parabola and let P at square comma 2at be any point on the parabola. So this is our parabola, y square equals to 4ax. Now this is our axis, this is our tangent at the vertex, and this is our directrix. So this is focus, this is a comma 0. So this is our vertex A, which is at the origin 0 0. Since y square equals to 4x is the standard form of the parabola, this is the principal axis x dash, this is our directrix, and this is our tangent at the vertex. So what do we need to prove is normal chord at the point P. So let us suppose that this is our tangent, for example. Let us suppose that this is our tangent at P. Then this is our normal. This is our normal. So what is a normal? Normal is a line which is passing through this point of contact and perpendicular to the tangent, this. So this point is given at square comma 2at, and q is the other end of this normal. So this is the normal chord. So this normal chord at a point other than the origin. The vertex is the origin here. Other than the origin, the normal chord is drawn other than this origin only, whose ordinate is equals to its abscissa. Given that ordinate is nothing but y coordinate, abscissa is nothing but x coordinate. Given the condition is 2at equals to at square. So from this a on both the sides, t gets cancelled. Therefore t is equals to 2. Then this chord subtends right angle at the focus. So at here 90 degrees is what we need to prove. That is PQ is this. PQ is a chord and here focus S is there. So this PQ chord should be at right angle at the focus is what we need to prove. That means angle PSQ is equals to which it is sufficient for us to prove slope of SP into slope of SQ is equals to -1. Product of the slopes is equals to -1. Then PSQ is equals to 90 degrees. That is what we need to prove. So here, what is P here now? At square comma 2at. T is equals to 2. 2 square is 4a comma 4a. P is equals to 4a comma 4a. Now equation of the normal, because at this point P, this is our normal. Equation of the normal at P 4a comma 4a is y plus xt is equals to 2at plus at cube. Parametric point. Y plus xt is equals to 2at plus at cube. So this implies y plus x into t is 2. So 2x is equals to 2at. 2 2s are 4 into a 4a plus at cube. A into 2 cube 8. 8 into a 8a. So this is equals to y is equals to 12a minus 2x. So one point of this normal chord which is 4a comma 4a, which we have known already. So we need to find out the other end of this normal chord which is q. For this, let us try to solve this. Let us try to substitute this into y square equals to 4ax parabola. So substituting y in y square equals to 4ax, we get. So what is the value of y? 12a minus 2x whole square is equals to 4ax. Is equals to 4ax. So this is equals to, if you take 2 as a common here, then this is 6a minus x whole square is equals to 4ax. So 2 square is 4. 4 on both the sides gets cancelled. So we are left with 6a minus x whole square is equals to ax. This is equals to 6a whole square, a minus b whole square, 36a square plus this is x square minus 2 6 are 12, 12ax is equals to ax. This is equals to 36a square plus x square minus 12ax minus ax is minus 13ax equals to 0. This is clearly a quadratic equation in terms of x. So this is x square minus 13ax plus 36a square equals to 0. 136, 36, 4 9s are 36, 4 and 9. Minus 4 minus 9 is minus 13. So this is x square minus 4ax minus 9ax plus 36a square equals to 0. Take x in common, then this is x minus 4a. Take minus 9 x in common. Take minus 9a in common, then this is x minus 4a. So is equals to 0. From this, x minus 4a equals to 0. This is x minus 4a into x minus 9a equals to 0. From this, x is equals to 4a comma 9a. So substituting this x in y will get, so x equals to 4a comma 9a is what we got. Substituting this x in y is equals to 12a minus 2x. So if x equals to 4a, substitute in this y, then this is 12a minus 2 4s are 8a. This is 4a. Therefore, one point is P 4a comma 4a, which we already got earlier. This is 4a comma 4a, which we got earlier itself. Now we need to get this point Q. So if x is equals to this 9a, then y is equals to 12a minus 2 9s are 18a. This is equals to minus 6a. Therefore, what is the Q here? Q is 9a minus 6a. Therefore, these points are what we get now. So P is 4a comma 4a and this is 9a comma minus 6a. Now, so to prove angle PSQ is equals to 90 degrees. So slope of PS and slope of QS, slope of PS and slope of QS is equals to minus 1 is what we need to prove. Slope of PS is equals to, so this is a comma 0. So this is x1 by 1, this is x2 by 2. So slope is y2 minus y1 by x2 minus x1. This is 4a minus 0. 4a minus 0 by 4a minus a. So 4a by 3a, which is equals to 4 by 3, and slope of SQ is equals to minus 6a minus 0 by 9a minus a. This is equals to minus 6a by 9a minus a is 8a. A gets cancelled. This is minus 3 by 4. Here, slope of PS and slope of SQ is 4 by 3 into minus 3 by 4. Slope of PS into slope of SQ is equals to how much? 4 by 3 into minus 3 by 4. 4 gets cancelled, 3 gets cancelled, minus 1. Since product of slopes are minus 1, therefore angle PSQ is equals to 90 degrees. is what we need to prove.